All right, so we're going to look at something called arithmetic and geometric means, all right, which is when we take an arithmetic or geometric sequence and we leave out some of the terms in between, not the beginning and not the end, but we give you like two values and tell you how many terms are missing in between those two, and you fill them in, okay? So it's very important that you have a method to solve this. You do not want to just count on guessing and checking your way there. All right, so in this first set, we're going to be told this is definitely an arithmetic sequence, each table. That's important because there's nothing in the table. Having only two values, the 5 and the 11, does not indicate what type of sequence was used to get there. It's only because we're told it's an arithmetic sequence that we know we must have added something. Well, what did we add? It's an unknown amount, our common difference, but it happened twice, right? We added some number to get from 5 to this blank box, and then because it's an arithmetic sequence, we know we added the exact same number again to get to 11. So what happened was we added m twice to get from 5 to 11. So we can turn that into an equation. Now, technically, we're saying we started with 5, we added m, then we added m again, and it was equal to 11. Now, you will probably not want to start with that step. We can start at the very next step and write our equation originally as 5 plus, now adding m twice is 2m equals 11. All right, that's just a simple linear equation to solve, so we subtract 5 from both sides. That means 2m must equal 6. Divide both sides by 2, leaving you m is equal to 3. So let's try that out. If m is 3, if our common difference is 3, then 5 plus 3 would be 8, and 8 plus 3 does give us the 11 that we're supposed to hit. Okay, so this m that we find is our common difference. And then we go back and apply it to fill in however many terms are missing. Okay, now number 2, again, we're still assuming it's an arithmetic sequence from the directions, but this time, whatever that common difference is to be, we add it once, twice, 3 times, 4 times. Please don't make the mistake of counting the empty boxes and thinking that's how many times you added the common difference. You actually need to do it one time more than the empty boxes. For example, in number 1, there was 1 empty box. We had to add m twice. Here we have 3 empty boxes. We have to add m 4 times. So my work for number 2, I would say I started at 18. This is number 2. I started at 18. I added m 4 times in order to reach negative 10. So what would m have to be? If we subtract 18, 4m is negative 28. Divide by 4, m is negative 7. Let's try that out. 18 plus negative 7, or subtract 7, is 11. 11 plus negative 7 is is 4. 4 plus negative 7 is negative 3. And negative 3 plus negative 7 is negative 10. Number 3, we're starting this time at 12. Then we are adding m 1, 2, 3, 4, 5, 6 times. So plus 6m is equal to negative 6. To solve that little linear equation, subtract 12 on both sides. 6m is negative 18. Divide by 6. M is negative 3. Try it out. 12 and negative 3 is 9. Another negative 3 is 6. Again is 3, 0, negative 3, and we land at negative 6. So describe your method for finding the missing terms, and will it always work? How do you know? Well, I'll leave that to you to put this method into your own words. You describe it so that you will understand. If you have something else that seems to work different from what I did here, feel free to explain that. All right, let's go ahead and apply what we just tried out in 3 more tables, okay? So we're going to stick with arithmetic sequences for now and say, okay, in number 4, we needed to add that common difference once, twice, 3 times. So 50 plus 3m is 86. Subtract 50 from both sides. 3m equals 36. 3m equals 36. I need to divide by 3. M is equal to 12. So if we add 12, we get 62. Add another 12 is 74. Add another 12, 86. Number 5. Start with 40. Add m once, twice, 3 times, 4 times, 5 times. So 40 plus 5m equals 10. Subtract 40 on both sides. 5m equals negative 30. Divide by 5. M is negative 6. Okay. 40 subtract 6 is 34. Minus 6 is 28. Minus 6 is 22. Minus 6 is 16. Minus 6 gives me 10. And the last one in this set, number 6, we're starting out at negative 23. We're going to add m once, twice, thrice, 4 times, 5 times, 6 times, 7 times. So plus 7m to get us to 5. To get rid of negative 23, we add 23 to both sides. So 7m equals 28. Divide both sides by 7. M is 4. So common difference of 4, if I add 4 repeatedly, negative 23 plus 4 is negative 19. Add 4 is negative 15. Add another 4. Add another 4. Add another 4. Add 4 more. And finally add 4, I get to 5. Okay. Now let's try that same problem, that same situation, but if we just change to geometric sequences. All right. So again, we have something to start with, a place to end up, but we're missing 1 or more terms in the middle. Okay. So in number 1, if we think from 3 we had to multiply by some value, let me call it r, and then to get that was to get the second term, and we took that term and multiplied by r again to get to 12. Okay. So we're going to just adapt our last method to work here with multiplication with geometric sequences. So we start out with 3, but rather than adding here, we're now multiplying by r, and then by r again, and ending at 12. Well, once again, this is probably one step more than you need to show. R times r, we all know, is r squared. So we can probably just start out with saying 3r squared equals 12. To solve that, divide both sides by 3. So r squared is 4. And then to get rid of the squared, the inverse of squaring a number is to take its square root. However, we know, I hope, that when you take the square root of both sides of an equation, there are always 2 answers, 1 positive and 1 negative. So the square root of 4 is 2, but ours can be both positive 2 and negative 2. Now, that's really what this question here is asking us. Is the missing term we identified the only answer? Well, for example, if you had chosen 2, if you had only found 2 for your common ratio, 3 times 2 is 6, 6 times 2 is 12. It worked. But that's not the only answer. No, it isn't. Because we could also have used negative 2. Now, if we had used the negative, then 3 times negative 2 would have been negative 6. And multiply that by negative 2, we're still back to 12 like we need to. So the second term could also be negative 6. Now, as we move on here, we want to try to ask ourselves, why did that happen? When will it happen? When can we expect two possibilities, and when will there only be one? Okay. So number 2, this time we're going to multiply by that common ratio once, twice, 3 times. So if we start with 7, and if we multiply by the same number 3 times, that's like saying r to the third needs to equal 875. Okay, solving this, we want to divide both sides by 7. So r to the third is equal to, let's see, that's 125. And then the inverse of r cubed, we will take the cube root of both sides. And that's just what you think it means. It's like square root, except cube root means what number times itself 3 times gives me r cubed. Well, r. What number times itself 3 times is 125? And that is 5. Now here, we do not have 2 possibilities. Negative 5 cubed would not be 125. It would be negative 125. So we only get the one value for our common ratio. So 7 times 5 is 35. 35 times 5 is 175. And 175 times 5 is 875. Okay. Oh, there's the rest of my number 2. Are the missing terms that you identified the only answers? So when we had 35 and 175, are those the only answers? Yes, they are. And the reason is really why that happened is we only have one possible common ratio because the exponent was odd. And by exponent, I mean the third. Since we did 1, 2, 3, we wrote our equation 7r cubed equaled 875. This exponent being odd tells me I'm only going to get one possible common ratio. Okay, number 3. This time we're going to multiply 6 by some common ratio once, twice, 3 times, 4 times. So 6 r to the 4th is equal to 96. If I divide both sides by 6, r to the 4th is 16. And now I would want the 4th root of both sides, giving me r is both positive and negative 2. Now, why are there 2, a positive and a negative? It's because 2 times 2 times 2 times 2 is 16. But it's also true that if I have negative 2 multiplied by itself 4 times, these first 2 become 4, the next 2 become 4, so 4 times 4, that's also positive 16. It's because there was an even exponent here. So I'm going to split these boxes in half and go through the 2 possible answers that we could have for each of these. So if we use the positive 2 as our common ratio, 6 times 2 is 12, times 2 is 24, times 2 is 48, and times 2 is 96. But if we had chosen the negative 2, 6 times negative 2 would be negative 12, times negative 2 is still 24, times negative 2 is negative 48, times negative 2, back to 96. So, are whichever set you identified the only answers? No. And it was because of the positive exponent equals 2 possible common ratios. Okay, number 4. This time, our common ratio is going to be used 1, 2, 3, 4, 5. 5 times. So 4 r to the 5th equals 972. Divide both sides by 4. So r to the 5th equals, let's see, 4 into 9 goes twice, leaves 1, goes 4 times, 243. And to solve for r to the 5th, solve for r, from r to the 5th, we need to do the 5th root of both sides. Well, that gives us r equal to 3. I only get the positive because this, again, was an odd exponent. We're only going to get one possible answer. So our r value, our common ratio is 3. 4 times 3 is 12. Times 3, 36. Times 3, 108. Times 3, 324. And times 3 is 972. Are those the only answers? Yes. It's because we had an odd exponent. All right, and I will allow you to write your own explanations for A and B. A, you're describing the method for making this equation, and B, you're explaining how you know whether there will be one answer or two answers, and that is, again, based on whether there's an odd exponent or an even exponent.